Hello everyone, this is Tanima. This video is streaming in my YouTube handle at the rate just Tanima_Barbie. Just to let you know, my YouTube venture is totally a personal endeavor as a voluntary virtual social outreach, and it has nothing to do with my profession where I'm engaged with research and teaching in the field of molecular biology and biotechnology in an institution in India. I personally believe that education should be freely accessible to all, and with this in mind, I have initiated a series on cancer biology. This is my fifth video on cancer biology. In continuation to my previous video, the present video discusses another perspective of unlocking phenotypic plasticity, that is transdifferentiation, in the topic of hallmarks of cancer. This video partially discusses the paper entitled Hallmarks of Cancer New Dimensions. The DOI of the same has been pasted in the description box. I would also request you to turn on the subtitle or caption button on your screen in case you find difficulty with my deliberation. Do keep watching. The concept of transdifferentiation has been well known to pathologists through the phenomenon of tissue metaplasia. In this process, cells of a specific differentiated phenotype significantly change their morphology to resemble elements of another tissue. A notable example is Barrett's esophagus, where chronic inflammation of the esophageal stratified squamous epithelium leads to its transformation into a simple columnar epithelium, characteristic of the intestine. This change facilitates the development of adenocarcinomas instead of the expected squamous cell carcinomas from the squamous epithelium. Today, molecular determinants are uncovering mechanisms of transdifferentiation in various cancers, both in cases with evident tissue metaplasia and in more subtle instances, as illustrated in the following examples. An illustrative example of transdifferentiation as a distinct event in tumorigenesis is seen in pancreatic ductal adenocarcinoma or PDAC. In this case, pancreatic acinar cells, one of the implicated cells of a region, can transdifferentiate into ductal cell phenotype at the onset of neoplastic development. Two transcription factors or TFs, that is PTF1A and MIST1, regulate the specification and maintenance of differentiated pancreatic acinar cells through self-sustaining feed-forward regulatory loops. These TFs are often downregulated during the neoplastic development and progression of PDAC in both humans and mice. Functional genetic studies have shown that experimentally enforced expression of PTF1A can impair KRAS induced transdifferentiation and proliferation and can even induce redifferentiation of neoplastic cells back into a quiescent acinar cell phenotype. Conversely, suppressing PTF1A expression triggers acinar to ductal metaplasia, making the duct-like cells more susceptible to oncogenic KRAS transformation and accelerating the development of invasive PDAC. Similarly, forced expression of MIST1 in KRAS expressing pancreatic cells blocks transdifferentiation and hampers the initiation of pancreatic tumorigenesis, while genetic deletion of MIST1 enhances the formation of premalignant duct-like lesions and the initiation of KRAS-driven neoplastic progression. The loss of PTF1 and MIST1 expression during tumorigenesis is associated with increased expression of another developmental regulatory transcription factor, SOX9, which is normally involved in ductal cell specification. Forced upregulation of SOX9, bypassing the need to downregulate PTF1A and MIST1, has also been shown to stimulate the transdifferentiation of acinar cells into ductal cell phenotype that is sensitive to KRAS-induced neoplasia, implicating SOX9 as a crucial effector in the development of human PDAC. Therefore, alterations in the regulation of these three transcription factors can induce a transdifferentiated state that, in the context of KRAS mutation, facilitates oncogenic transformation and the initiation of tumorigenesis and malignant progression. So, viewers, hope this video could provide further insights into the topic of hallmarks of cancer. Please don't forget to like and share my video and also subscribe to my channel. Here, I would like to mention that the references that were used in the video have been pasted in the description box, and if you're interested to look into the details, you might check the same. Hope to meet you soon with yet another video on cancer biology. Till then, do take care and keep up. Bye.